This video is to help you understand normal curves and distributions and just the main kind of topics about normal curves. So the first thing you need to know is density curves. The main overarching kind of vocabulary word for normal curves begins with density curves, and density curves are the broad generic kind of curve. They represent 100% of the data. The area under the curve is 100%, and they are always above the x-axis. Now these curves are not normal. They don't have to be, so they could look like a box, they could look like a skew and go up, but these are the three kind of main ideas for density curves, and normal curve is a special kind of density curve. And the special kind of density curve is normal because of these qualities. It's perfectly symmetric, there's one single peak, it is shaped like a bell. And then the two things that you need to describe them fully would be the mean and standard deviation. The mean always goes in the center. This is the symbol for mu. And then standard deviation, you add it once, twice, three times. You subtract it once, twice, three times. And this is the total picture of your curve. And then the next topic, moving on, is the way the curve is shaped. Now, the standard normal curve has 0 in the middle, and this is represented by the mean, and the standard deviation for standard normal curve is 1. And so from the middle, 0, add 1, you get 2, add 1 more and you get 3, subtract 1, you get 1, negative 1, subtract 1, negative 2, subtract 1, again, negative 3. Now the standard normal bell curve has this really great rule that you can use to find probabilities under the curve, but you have to be on one of these exact deviations. You can't use this rule if you're at 0.8 or 1.7. Nothing in the middle will work with this rule of thumb. So the rule of thumb works like this. One deviation away from the mean contains 68%. Two deviations away from the mean contain 95% of the data, and 3 deviations from the mean contain 99.7% of the data. So if 68% is within one deviation, then that gets split up equally in these two kind of sections. So 68, if you divide it in half, would be 34% here and 34% here. And now I've used 68%. So if I take 95, I subtract 68, this is the percent that will be left to use in these two sections that make up in total 2 deviations away from the mean. So I'm going to take my calculator, turn it on. I will take 95, subtract the 68 that I already used. That means I have 27% left, and I want to split it up equally in these two sections, so I'll divide that in half. And that means this section over here has 13.5% of the data, and this section over here is 13.5% of the data. Now these 4 sections total is 95, and I have for 3 deviations away, so negative 3 to positive 3, will contain 99.7. So I'll take my calculator, 99.7, subtract the 95 that I've already used here. That means 4.7% of the data lies in here. Now my picture isn't, perfectly drawn to scale, but if I take that section and split it up equally here and here, that means that in this section, 2.35% of your data should land between -2 and -3 deviations from the mean, and 2.35% here above, from 2 deviations to 3 deviations above the mean. And now what's left, if your curve is supposed to represent, like I said before, 100% of the data, I've used up in these 6 sections 99.7, so 100% minus 99.7% would be 0.3%, split that in half, and this would be 0.15% of the data, and over here 0.15% of the data. Now these are in percentages, so decimal form would be 0.0015, so incredibly small percentage below 3 deviations, and that's why typically your curve only goes from -3 to 3.